Hi, and welcome to this section of the Basic Math Word Problem Tutor. And in this section, we're going to continue our theme of word problems involving fractions. And in this section, we're going to tackle word problems that involve multiplication of fractions. So we're moving through things in a very logical order. We've done adding and subtracting, and now multiplying of fractions. Now the good news is if you haven't done much multiplication with fractions in practice or in school or in class or anything, the good news is multiplying fractions is really easy, okay? In fact, I think multiplying and so dividing, you'll see in the next section, dividing and multiplying fractions are actually easier than adding and subtracting them. And the reason is because remember back when we did the adding and subtracting of fractions, we had to find that common denominator. We had to make that bottom number in both fractions that we were adding, we had to make that the same, okay? And you just can't add fractions or subtract them unless you do that, okay? Well, in multiplying fractions, what you'll see here in a second when we do it, if you have two fractions and you would like to multiply them together, it's very easy to do. All you do is you multiply the top two numbers to get your new top number, and you multiply your bottom two numbers to get your new bottom number. There's no common denominator, there's no playing around with it to make it into some new form like we had to do on the adding and subtracting. You multiply the top, you get the new top, you multiply the bottom to get the new bottom. So after that, it's just really simple. You just simplify your fraction just like you normally do. Okay, I think the easiest way to do this is to go ahead and just work some example problems. We've got quite a few in this section because I really want to make sure you understand it. And so we're going to go through them step by step. So the first one says, what is the total length of 4 pieces of wood if each piece measures 2 3/4 inches long? Okay, so the first thing you need to do when you read a problem is read it more than once and make sure you truly understand what it's saying. So it says, what is the total length of 4 pieces of wood if each piece measures 2 3/4 inches long? Okay, so we know we're not going to be we're not going to be adding or subtracting anything here. First of all, you just look at subtraction. Subtraction doesn't make any sense at all because this problem is asking you for the total length of something. It means you're going to be either adding or multiplying to find the total length of something. You're definitely not going to be subtracting. Division doesn't make sense here because you're not trying to find out you're not trying to find out how big one little piece is when you know how big all of it is. You're actually doing the opposite. You're trying to find out how long is the total length if you know how big each piece is. So here's a piece 2 3/4 inches long, and I put it right next to another piece that's another 2 3/4 inches long, and another one that's the same length, 2 3/4 inches long, and then a fourth one that's 2 3/4 inches long. And I put the tape measure and I want to see how long that entire thing is. So what you're doing is you're adding up 2 3/4, 2 3/4, 2 3/4, 2 3/4, and you're doing that 4 times. And so when I say this out loud, you're doing it 4 times. That means you're multiplying by 4. You're taking the 2 3/4 and you're multiplying by 4 because you're trying to add all those up. And multiplication is just a shorthand way of addition. So if you had a piece of wood, just to draw a little picture, let's say it was this long, okay? And let's say, this is 1 inch here and 1 inch here, okay? So then let's say this is 1 inch and this is 1 inch and this is another inch here, but our piece of wood that we're actually interested in only goes to 3/4 of an inch. So this is 3/4 of an inch. So you see, what I'm trying to show you here in pictures is the entire length, let me go ahead and use a different color, that'll make it clear here. The entire length of what it is we're actually interested in adding up together is this length right here, okay? And this is 2 3/4 of an inch long, okay? That's what this means. 2 inches plus 3/4 of an inch, which is not quite a whole inch, okay? So what we're doing here is what we're going to take this length here, which is one piece of wood. This is how long my piece of wood is, and we're going to put 4 of them end to end, and we're going to find out what the total length is. So what we are doing is we are taking 2 3/4 of an inch, okay, and we are multiplying that by 4. And the dot here is just multiplication. So don't get scared off by this if you've never seen that dot before. That just means multiply. It's the same thing that you would see if you saw an X here like this. Okay, it just means multiply. So it's nothing new there. I like using the dots because they're smaller and they get out of the way more, and it makes your paper look cleaner. Okay, so this means multiplication. So 2 3/4 times 4. Now, how would you do this? You see, first thing you need to ask yourself is how would you do this? Well, here I've got this 2 and I've got this fraction, 3/4, and I'm multiplying by this, and so we know there's going to be some fractions involved, and this is what I recommend that you do. Every time that you see one of these mixed fractions and you're multiplying, what I want you to do is just convert it to what we talked about before, an improper fraction. So what we're going to do is we're going to take this one and we're going to convert it, okay, like this. Remember how to convert these things. You take the bottom times 2, 4 times 2 is 8, plus 3, so starting with 8, 9, 10, 11, is going to give you 11. And you just write it over whatever the bottom number of the fraction is here. So what we are saying is this fraction 11/4 is exactly the same as this fraction 2 3/4. It represents the same exact thing. Okay. So all you did was you took the 4 times the 2 to give you 8, plus 3 to give you 11. So you put the 11 and you write it over 4 because that's what your fraction is here. Okay. Now we're going to multiply by 4. Okay, so I could write 4 here like this and go on like this, but when you're multiplying fractions, you need each number to be a fraction. So let me ask you, if you were going to express the number 4, just the number 4, as a fraction, how would you do it? The answer is going to be 4 over 1. I think you might remember back from your basic fractions that anything over 1, any number can be written as itself over 1. So 4 over 1 is 4, okay? 6 over 1 is 6, 72 over 1 is 72, and so on and so on. So it's really just, the reason it's this way is because fraction is really the same thing as division, and so I think you all know that 4 divided by 1 gives you 4. So you see what we've done. We've taken this problem, this multiplication of fractions problem, and we've changed it a little bit, and you'll see why we did this in a minute. We took our mixed fraction and we converted it to this improper fraction. 4 times 2 is 8, plus 3 gives me 11, and then you just write it over 4. And then this other number here has to be in the form of a fraction, and we can write any number over 1 to make it a fraction. So let's see, why did we do this? Because I told you multiplication of fractions is super easy. It's one of the easiest things you will do. All you do, you take the top 2 numbers and multiply them together. 11 times 4 from your multiplication tables is going to be 44. So you just write that on the top. And on the bottom, you just multiply these. 4 times 1 gives you 4. Okay? So you see, we didn't have to find any common denominator here. We didn't have to do any tricks with the fractions to make the bottom numbers the same like we used to do in the adding and subtracting fractions. You just simply multiply the top 2 numbers and get the new number, multiply the bottom new numbers to get the new bottom number, and this is the answer. Okay? This is the answer. But people usually don't like you to leave fractions in improper form. And improper, by the way, just means it has a bigger number on the top than it does on the bottom. So we're going to fix that. Okay, let me ask you this. Remember, a fraction means division, right? A fraction means division. That is what a fraction is, okay? So when you take 44 and divide by 4, 44 divided by 4, what are you going to get? You just think back to your multiplication tables. 4 times what will give you 44? 4 times what will give you 44? The answer is 11, okay? So 44 over 4 as a fraction is exactly the same thing as 11. And that's the answer, 11 inches, okay? So we have to really make sure we understand this here. Every fraction is a division, okay? That's why we were able to do this. 4 divided by 1 gives us 4. That's why this is true, okay? And so on and so forth. So all you do is if you have a mixed fraction, convert it to improper, and we already talked about how to do that. If you have a whole number, you convert it to some sort of fraction. It's really just a simple rewriting. And then you multiply the top to give you the top, multiply the bottom to give you the bottom. Now this is the answer, but people don't really like you to leave the answer in terms of an improper fraction with a bigger number on the top, so you try to divide. 44 divided by 4 gives you 11. Okay? And that's the answer, 11 inches. So if you were to take 2 3/4 pieces of wood and stack them end to end to end to end, you would find in the end that you have 11 inches long there. Okay? So we're going to do a lot of examples here, a lot of problems here to make sure this is totally clear. Let's go on to the next one. A box of peanuts weighs 3 1/8 pounds. How much does a carton of 3 boxes weigh? Okay, so we know that we're going to be multiplying here because it tells us a box of peanuts, one box, weighs 3 1/8 pounds. Okay, but I'm not talking about one box. I'm talking about 3 boxes because it says how much does a carton of 3 boxes weigh? So what you're doing is you have 3 1/8 pounds here for one box, 3 1/8 more pounds for another box, 3 1/8 more pounds for another box. So you're adding them all together, you sure are. But because it's written in the form of, okay, you have 3 1/8 pounds for one box and 3 boxes, you're multiplying times 3 because you have 3 boxes. 3 1/8 pounds per box times 3 boxes. Okay, that's how you do a shorthand way of doing the addition. That's what multiplication is. So we're going to need to multiply here. And what we're going to multiply is 3 1/8. This is the weight of one box times, that's what the dot means here, 3 boxes. Okay, so we have the weight of one box times 3 whole boxes is going to give us the total weight of all of it. And it's exactly the same thing as before. We want to rewrite this into a nice clean fraction, something over something, and we want to rewrite this as a nice clean fraction, something over something. And then the multiplication is actually pretty easy. So let's do that. Starting with this. 8 times 3 is 24, plus 1 is 25. So I write that down, over 8. You always use the same bottom number that you had in your mixed fraction before. Okay? Again, 8 times 3 gives us 24 from your multiplication tables, plus the 1 up here gives you 25, and you just write it over 8. So it's pretty easy. And then you multiply by 3, but we want to write it as a fraction, and that's just 3 over 1. Any number can be written as a fraction as itself over 1, because 3 divided by 1 is 3. So what you've done here is you've changed the look of the problem, but this is exactly the same as what you had here. So now we're going to multiply. Okay? We multiply the tops. 25 times 3. What is 25 times 3 going to be? It's going to be 75, but if you don't remember that, you can just do that real quick. 25 times 3. 5 times 3 is 15, so I'll put the 5, carry the 1. 2 times 3 is 6, plus 1 is 7. So that's how you get 75. Now, the way I honestly remember it is I know that a quarter is 25 cents, and 3/4 is 75 cents. So I just remember that from my money. So 25 times 3 is 75. So top number times top number gives me my new top number. And you multiply the bottom number separate. 8 times 1 gives me 8. So you've done your multiplication. This is the answer, but again, it's an improper fraction, and you really don't like to leave things in terms of improper fractions. You have a bigger number on the top than the bottom. So what you want to try to do is rewrite this. Okay? So let me ask you this. Because this is division, okay, how many times does 8 actually go into 75? Well, let's think about our multiplication tables here. 8 times 9 is 72 from your multiplication tables. So it can definitely go 9 times at least, because 8 times 9 gives you 72. So that's almost right. And 8 times 10, if we go one more, try to go 10 times, is 80. So that's too many. It definitely does not go 10 times, but it does go 9 times, because 8 times 9 is 72. So if I were going to just go ahead and write this down as a real division to show you what I'm talking about, what we're saying is it goes 9 times in here. Okay? And 8 times 9 is 72, right? And we always subtract, and we get a remainder of 3, because 75 minus 72 is 3. So you see, it doesn't go a whole number of times, because it goes 9 times for sure, but you have 3 left over. So you can't just throw away this 3 that's left over and just get rid of it and forget about it forever. You have to carry it along. So what you're saying is it goes 9 times with 3 left over. So you write it as 3 over 8. Okay? So I want to make sure you really understand what we did there. We converted this improper fraction back to a mixed fraction. So all you have to do is find out how many times does 8 actually divide into 75, and we said it was 9 times. But that only gives you 72, right? The difference between 72 and 75 is 3, so we write it down as 3, and we have to keep our fraction here, okay? So what you're saying is 75 divided by 8 goes 9 3/8 times. Okay, and this is the answer in mixed fraction form. Now, either one of these are actually correct, but most people on your test, they really want you to write it in this form. Okay, so the answer to the question is, if you had a box of peanuts that weighed 3 1/8 pounds, and you had 3 of them, then the entire thing would be 9 3/8 pounds. Okay, that would be the answer. Okay, the next problem says it takes 3.5 cups of batter to make 1 cake. Okay, how many cups of batter does it take to make 2.25 cakes? Okay, so this is an interesting problem because, you know, when you make a cake, you have to mix this batter together, right? So you have eggs and flour and sugar and other things, and you mix it together, and you measure it in a cup, you pour it in the cake pan, and you bake it. It makes a cake. So what it's telling you is it takes 3.5 cups, just think about how big a cup is, 3.5 cups of batter to make 1 cake. But I don't want to make 1 cake. I want to make 2.25 cakes. So I'm not even making 1 or 2 or 3 cakes. I'm not even making a whole number of cakes. I only want to make 2 plus another quarter of a cake. Okay, so how much batter do I need? Okay, well, if you think about this, if it were a whole number of cakes, I mean, if it were 2 cakes, let's say you were trying to make, then you would just double the amount of the batter. If you needed this much batter to make 1 cake, and you were trying to make 2 cakes, you would just double it, okay, to make 2 cakes. Okay, so you'd be multiplying by 2 in order to make 2 cakes, because you know how much batter it takes for 1 cake. If you were trying to make 2 cakes, you would just multiply by 2. But we're not making 2 cakes, we're making 2.25 cakes. So all you do is, instead of multiplying by 2, you multiply by 2.25. And that will give you exactly the amount of batter you need. So it's the same thing. You're multiplying by however much cake you want, which is not 2, it's 2.25. Okay? So let's do that. We know that it takes 3.5 cups of batter to make 1 cake. But we don't want to make 1 cake. We're going to multiply by 2.25 because we're actually trying to make 2.25 cakes. Okay? So this is what we're doing. We're multiplying 3.5 times 2.25. And how do we do that? Well, we have 2 mixed fractions. Okay? So we want to convert these to our improper fractions, and then that makes our multiplication really easy. Okay? Makes our multiplication really easy. So let's do this. How do we convert this? 2 times 3 gives us 6, plus 1 gives us 7, and you just write it over the bottom number here, which is 2. Okay? And this one is the same kind of thing. 4 times 2 gives us 8, plus 1 gives us 9, and you just write it over 4, which is its bottom number. And don't forget, we're multiplying these together. That's what we're doing. So these representation of these fractions here are exactly the same as these up here. It's just that these look different, okay? But they're exactly the same. They mean the same thing. They mean the same amount, okay? 2 times 3 is 6, plus 1 is 7, over 2. 4 times 2 is 8, plus 1 is 9, over 4. Now let's go ahead and do this multiplication. We're doing multiplication of fractions. We just multiply the tops. 9 times 7 is 63 from your multiplication table, so that's the top number. Okay, and you don't have to do anything else on the top. Just multiply 9 times 7 is 63, and 2 times 4 is 8. Okay, so that becomes your new bottom number. And this is the answer. This is the answer, 63 over 8. That's how much batter you need. But you see, 63 over 8 doesn't really tell you much, and it's because you've got this giant number on top and this little bitty number on the bottom. And so, like I was saying before, you're always going to want to convert this back to a mixed fraction if you have a bigger number on top. So let me ask you a question. Since a fraction really is division, so this is really 63 divided by 8, how many times does it go in there? 8 times what will give you 63, or close to 63? Well, 8 times 5 is 40. Okay, so that's too little. 8 times 6 is 48. That's getting closer. 8 times 7 is 56, right? 8 times 7 is 56. And 8 times 8 is 64. So that's too big. 8 times 8 is 64, and we're only shooting for 63. So we know it can't go 8 times. So let's back up a little bit. 8 times 7 is 56. So we know it goes 7 times, but that only gets me to 56. Okay? So 63 minus 56, what does that equal to? Okay, what does that equal to? Well, we're going to subtract 6 minus 3. That's 13. Borrow and make this a 5. Okay, we can't take 6 minus 3, so we have to borrow. Now, what's 13 minus 6? Starting at 13. 12, 11, 10, 9, 8, 7. So it's going to be 7. So 63 minus 56 is 7, because this 5 minus 5 gives you 0. So you write this over here. Since there's 7 left over, that's 7 over 8, because that's your bottom number. Your bottom number is going to hang along for the ride here. Okay. So let me make sure you understand what we did. The answer is 7 7/8 cups of batter. Okay, that is how much batter we need to make 2 1/4 cakes. Okay, so what we did is we converted these mixed fractions to improper fractions because it made it very easy for us to multiply. Top times top gives us top, bottom times bottom gives us bottom. And then now that we're here, we just try to go ahead and divide and see what happens. So we know that 8 can go into 63 7 times, but that doesn't get us all the way to 63 because 8 times 7 is only 56. So we get close to 63, but not all the way there. And then we just take the 63 minus the 56 to see how far away, what the remainder is. That's what we're trying to do. How much is left over after we divide there. And then we write that as a fraction, 7/8. Okay? So what you're saying is 8 goes into 63 7 7/8 times. Okay? That's what that means. And so because of that, that's how much batter you need in cups. And that's very useful, by the way, because measuring cups actually have fractions written right there on the cup. You can read to 3/4 and 1/3 and 5/8 and things like that. So you can actually measure 7 7/8 cups of batter. Okay, you can do that. Let's get some more practice with this. And we'll say that Jenny is 11 3/4 years old. Okay, you are 1/4 of Jenny's age. How old are you? Okay, that's the question. Okay. So Jenny is 11 3/4 years old. That just means she's almost 12. Okay, she's definitely already made it to 11. She's 3/4 of the way to making it to 12. So she's 11 3/4 years old. You are 1/4 of her age. Now this phrase, by the way, 1/4 of her age usually means multiplication. Of is sometimes a good keyword to look for multiplication. But even if you don't quite understand the keywords to look for, you know you need to multiply here because, think about it. If she was 11 3/4 years old, and if the problem were changed, and the problem said, and you are twice her age, then what would you do? You would multiply by 2 to double her age, right? Or if the problem said, you are 4 times Jenny's age, 4 times Jenny's age, then you would multiply by 4, right? Well, this one, it looks like it's more complicated, but it's really not because it says you are 1/4 of her age. So that's no different than the number 2 as in twice as much, or 4 as in 4 times as much. 1/4 just means that instead of making it bigger, you're going to chop it down because a fraction is less than 1. So multiplying by 1/4 is going to make your age smaller than hers. And that makes sense because the problem says you're only 1/4 of her age. That means you're 1/4 of her age, okay? So what we're going to do then is we're going to multiply these things together. We have 11 3/4 years old, that's Jenny's age, and we're multiplying by 1/4. Okay? Because you are 1/4 of her age. So if you multiply these together, you're going to get an answer that's smaller than her age, and you're only going to be 1/4 of her age. So the first thing we need to do is we need to change this mixed fraction into an improper fraction so we can do an easy multiplication. So how do we do that? Same thing that we did before. 4 times 11 from your multiplication tables is 44, plus 3 is 45, 46, 47. So you're going to write down 47 over the bottom number, over 4. So that's how you do that conversion. 4 times 11 is 44, plus 3 is 47. And we're multiplying by 1/4, and we didn't have to do anything to this because it was already in the form of a fraction. So we're in great shape to go ahead and press on. We just multiply the tops. 47 times 1 gives us 47, and the bottom, 4 times 4, from your multiplication tables gives you 16. So the answer here is 47/16, or 47/16. That is your age. And by the way, this is in years. You're 47/16 years old. Well, that's kind of hard to visualize what that means because we're not used to dealing with fractions with such big numbers on the top and little numbers on the bottom. So because of that reason, and just because in your test they like you to do this, we're going to convert this fraction back to a mixed fraction, which is the same thing. It's just a little bit easier to read. Okay? So let's do that. Remember, fraction is the same thing as division. So what we're doing is we're dividing 47 by 16. How many times do you think that goes? Okay. Well, let's see here. 16 times 1 gives us 16. So we know that at least goes one time. Okay. 16 times 2, if you don't know how to do that in your head, we'll just do it here. 16 times 2, 6 times 2 is 12, carry the 1. 1 times 2 is 2, plus 1 is 3. So 16 times 2 is 32. That's pretty darn close to 47. So we're getting there. Let's try 16 times 3 and let's see if we get any closer. 6 times 3 is 18. Carry the 1. And 3 times 1 is 3, plus 1 is 4. That's 48. This is 47, so we know it cannot go 3 times because that's too many. That's too big. Okay? It can only go 2 times. And even then, there's a difference between the 32 and the 47 that we have there. So we're going to have a fraction in the end. So we know that 16 can be divided into 47 2 times. Okay? What's going to be left over? When we multiply by 2, we got 32. So what's left over between 32 and 47? We just subtract them. Okay, we just subtract them to find out what the difference is. What's left over? Okay, because when we divided into it, it didn't go all the way in. We had some left over. So 7 minus 2 gives you 5, and 4 minus 3 gives you 1. So we have 15 left over. So since we have 15 left over, we write it here, and we just write it over our denominator, just like we've always been writing it, and that's how you convert back. So to summarize, your age is 2 15/16 years old. Okay? And just to tell you a little bit more about what this means that if you really are 1/4 of her age, okay, then you're almost 3 years old, because you definitely have 2 years right here. And the 15/16, don't ever forget what a fraction means. It means if you divide a pie into 16 pieces, because of the 16 down here, you have 15 of those pieces. So almost an entire pie, or in this case, since we're talking about years, almost an entire additional year. So you're almost 3 years old, okay? Not quite, and that's what the fraction tells you, but you're almost 3 years old. So what we did is we converted this by taking 4 times 11 is 44, plus 3 gives me 47, and you write it over your denominator, which is 4. Multiply by the 1/4, top times top gives us top, bottom times bottom gives us bottom. The only thing to really think too much about is how to do this and convert it back. 16 goes into 47 only 2 times, okay? And that gets us up to 32, and the difference between 47 and 32 is 15, so we write it as 15/16, and that is the answer. Okay, the next question says, a car travels at 9.5 miles per hour, and after 3 1/3 hours, how far have you traveled? Okay, so we want to think about this logically, and then I'm also going to show you the units and how you can help figure out what to do by knowing how to use the units as well. But even before we get to that point, think about this. A car is traveling 9.5 miles an hour, and that means that every single hour it goes another 9.5 miles. So in the first hour it's 9.5 miles, and then 1 more hour later it's gone another 9.5 miles, and then after another hour it's gone another 9.5 miles, and so on and so on. Every hour is another 9.5 miles. Okay? So if you're on the road for 3 1/3 hours, which is just a little bit more than 3 hours, how far have you gone? You know that you need to multiply here because you're trying to find the total distance you've traveled in miles. You know how fast you're going, how many miles every single hour. So if you multiply that by the number of hours you're on the road, in this case 3 1/3, that will tell you how far you've gone total. So you're taking your speed times your time, and you're finding the total distance traveled. Okay, so that should hopefully make sense to you from a point of view of just thinking about you have so many miles per hour times the number of hours you're on the road gives you the total distance you've gone. But even if you have no idea if you should multiply or divide or whatever, you can always use your units. So in this case, you have 9.5, and the unit is miles per hour. And this little bar here, don't forget from our other sections, just means per. So it means 9.5 miles per hour, which is also kind of a division line. It's like being divided as well. Okay, so you're trying to figure out, let's say, if you should multiply or divide these things together, and let's just say that you wrote it like this: 3 1/3 hours. Okay, let's say you were going to try to do this, and this would mean multiplication because these are both on the top. 9.5 times 3.5, they're multiplied. Anything on the bottom is divided by. Okay, now because hours is on top and hours is on the bottom, they can divide out. Okay, they're dividing out here the same exact way that 3 over 3 is 1 and 2 over 2 is 1. Well, hours over hours is 1. So that's why they disappear, because when you write it like that, they just go away. They go to 1. Okay. So anything on the top and the bottom, if they're the same thing, they disappear. So what this means is that if you were to multiply these together, the units would work out, so you would be left with miles, and that's why you know you should multiply. If you were not sure and you put this down here thinking that maybe you should divide these, the 3 1/3 hours if it were down here and this were blank up here, you would be dividing, then none of the units would cancel. You'd have miles, hours, and hours. None of the units would cancel, and you would not have the units you wanted. And so you would know that division is wrong. So all I'm showing you is that you can use the units to make sure and understand that multiplying is the right thing to do here. 9 1/2 times 3 1/3. That is the right thing to do. And I'm just showing you that the units tell you that. Okay? First thing we need to do is convert these to improper fractions. So this one is going to be 9 times 2 is 18 for your multiplication tables, plus 1 is 19 over 2. Okay? And this one is going to be 3 times 3 is 9, plus 1 is 10 over 3. Okay? And they're multiplied together. So we've done enough of these where I hope this is making a lot of sense now. 9 times 2 is 18, plus 1 is 19 over 2. 3 times 3 is 9, plus 1 is 10 over 3, because that's its bottom number. And now that we have them in this form, we can multiply. Okay? 19 times 10 is going to give us what? Okay? If you're not sure of the answer to that, 19 times 10, you can just multiply it right here. Okay? 0 times 9 is 0. 0 times 1 is 0. Now we're moving to the next digit, so we have to put a 0 down here. 1 times 9 gives us 9. 1 times 1 gives us 1. And we add these together. 0 times 0 gives us 0. 9 plus 0 gives us 9. And 1 plus blank, which is 0, gives us 1. So it's 190. 19 times 10 is 190. So we just put 190 up here. And on the bottom, we just look at the bottom two numbers and multiply those. 2 times 3 gives us what? It gives us 6. Okay? So 2 times 3 gives us 6. So we put 6 on the bottom here. Now this is the answer. This is the total amount of miles that you travel, but you got a big number on top and a little number on the bottom, so we want to convert it back into a mixed fraction because it just looks better and it makes more sense. Okay? So what we're doing is we're dividing 190 divided by 6. That's what this is. 190 divided by 6. That is what we are doing. So let's go ahead and do that division here. 6 goes into 1 how many times? It goes 0 times because 1 is just too little. It's smaller than 6. So let's begin to look at 19. Okay? 6 times what gives us 19? Well, nothing exactly, but 6 times 3 gives us 18, which is pretty darn close. Okay? So it goes 3 times, and we subtract these, and 19 minus 18 just gives us 1. So after our subtraction, the next thing we always do is we drop down the next digit, and now we have 10. 6 goes into 10 how many times? Well, 6 times 1 gives us 6, and 6 times 2 gives us 12, which is too big. So it only goes 1 time. 6 times 1 gives us 6. Okay? Now, what is 10 minus 6? You could just do that on your finger, starting at 10. 9, 8, 7, 6, 5, 4. So I took away 6. I have 4 left over. Okay? So you see what happens here. Okay? I tried to divide this fraction because I want to see how many times 6 can actually go in there. Okay? And what I found is it goes 31 times. But because I'm done dividing, I have 4 left over. Okay? So what I know is it goes 31 times. That many times it goes in for sure, but there's 4 left over. So you write the 4 over the 6, just like we've been doing before. So it doesn't go in all the way up to 190. It goes in just shy of that. It goes in 4 shy of that. So we say it goes in 31 times. It has a remainder of 4, so we write it as 4/6. Okay? So after all of that, the answer is going to be 31 and 4/6. Okay? Now the final thing you always need to do with every single problem that you work with fractions is to find out, is this fraction in simplest form? In other words, is there a number I can divide into the top and into the bottom to make it even simpler? And the answer is yes. Because let's just say, if you were to divide both sides, both top and bottom, by 2, what would happen? 4 divided by 2 is 2, and 6 divided by 2 is 3. And that is simpler, okay? So again, I just want to stress, and by the way, this is miles. I want to stress that from this point on, you had the answer, okay? This is a valid answer, correct. This is a valid answer, that's correct. This is a valid answer, that's correct. After you've done this multiplication, you have the answer in your hand. You're just putting it into a better form. Because the question was asking, how far did you travel? Well, it's hard for me to visualize 196 or 190 over 6 miles. But it's a whole lot easier for me to look at this and say, well, I traveled 31 miles, 31 and 2/3 miles. That means almost 32 miles, okay? So that makes a whole lot more sense. 31 miles plus a little bit more, 2/3 of a mile. That's what this means, okay? And that's why you're doing this. That's why you're taking these fractions and you're beating them into the simplest form. Okay, and I'm trying to do that with you over and over again so that you get in the habit of it, okay? The next problem says a garden hose flows at a rate of 2 1/8 gallons per minute. After 5/8 minutes of filling a barrel, how much water is in the barrel, okay? So here you have a big giant barrel and you're putting water in it, and the water is coming out at a rate of 2 1/8 gallons per minute. That means that every single minute that clicks by, I'm putting another 2 1/8 gallons in. Remember, a gallon is like a jug of milk. So every minute I'm putting 2 1/8 of those things in that barrel every single minute, okay? Now, question is, after 5/8 minutes, how much water is in the barrel? Well, because this is fractions, a lot of people can get a little bit nervous about this and not be sure what to do. But think about it. If you weren't waiting 5/8 of a minute, let's say you were going to wait 5 minutes, okay? Something that's makes a little bit more sense to our brain, okay? If this is going in at 2 1/8 gallons per minute, okay, and you wait for 5 minutes, you would just multiply by 5, right, to find the total amount. Well, this is just a fraction, which is just a number less than 1. So because it's a fraction doesn't change the logic of what you're doing. It's 2 1/8 gallons per minute, and you're waiting 5/8 of a minute. So that's less than a minute, okay? You still multiply by the 5/8 to give you the total amount of water. So 2 1/8 gallons per minute, but I'm not even waiting a whole minute. I'm only waiting 5/8 of a minute. How much water is in the barrel? You multiply them together, just like you would do if you were waiting 3 minutes or 5 minutes or 10 minutes, okay? You multiply by 5/8 of a minute. But even if you didn't even know how to do that thinking, and if you were totally stuck, you can always use your units, okay? You have 2 1/8 gallons per minute. This is just straight from the problem. I'm not doing any math here. 2 1/8 gallons per minute, that's what this means, okay? And if you were to multiply by 5/8 of a minute, again, you weren't sure what to do, but let's just say you did, then you would notice right away that minute on the bottom and minute on the top, they disappear because one's on the bottom and one's on the top. So what this is telling you is, if you multiply 2 1/8 times 5/8, you will be left with gallons, and that's what you want because it says how much water is in the barrel, okay? That's how many gallons, okay? So you know you need to multiply. If you were wrong here and tried to divide by 5/8 of a minute, then you would have gallons, minute, and minute. None of the units would cancel, and you would have the completely wrong answer, okay, because you're looking for gallons. So let's go ahead and do this multiplication. 2 1/8 times 5/8, okay, times 5/8. So first thing we need to do is convert this to a improper fraction so we can do our multiplication. And we do that by saying 8 times 2 is 16, plus 1 is 17, over 8. We just write it over the same denominator, times, okay? And our fraction here is the same as it always was, 5/8. We don't have to do anything to it. It's perfect, okay? So now that we have these fractions, it's easy to multiply them. We just multiply the top, 17 times 5, and I don't know about you, I cannot do 17 times 5 in my head, so I'm just going to multiply 17 times 5 right here, okay? 7 times 5 is 35, so I'll put the 5 and carry the 3. And 5 times 1 is 5, plus 3, 6, 7, 8, okay? So it's 8. So 17 times 5 is 85, okay? 85 on the top. And on the bottom, 8 times 8 from your multiplication tables is 64. So you have gotten the answer. The answer is, at the end, you'll have 85/64 gallons of water. But this is an improper fraction because the top number is bigger than the bottom, and so I would like to get rid of that. I would like to make that and turn that into a mixed fraction because they just look nicer, and that's what people are going to want to see. So the question to you is, this is just simply division. 85 divided by 64, how many times can it go? Well, I tell you that it can only go one time because 1 times 64 is 64, but 2 times 64, if we tried to put it in 2 times, that's going to be 128. And so that's just way bigger than 85, so that's just not going to work. It can only go one time, okay? And the question is, what's left over? After it goes one time, it only goes in 64, right? So what's 85 minus 64? We have to find out what's left over. Because it only goes in one time, that only gets us up to 64. Now we have to find out how much is left between the 85 and the 64. So we're doing the subtraction. 5 minus 4 in this column is 1. 8 minus 6 in this column is 2. Okay? So there's 21 left over. So we write it as 21/64 left over. And that's how you write it as a fraction. Okay? So you see this is a little bit easier to understand. Instead of that giant mixed fraction here, okay? What this is saying is if you have a water hose putting out 2 1/8 gallon per minute and you leave it on for 5/8 of a minute, then at the end of the day, you're going to have 1 gallon plus 21/64, which is getting close to about half of an extra gallon, not quite half of a gallon extra. So it's a little bit easier to read. I mean, the 21/64 is still a big fraction, but it's at least you know that it's between 1 and 2 gallons. At least it makes that much sense to you, okay? Okay, the final problem says there are 20 students in a class. If 3/4 of the class makes an A, how many students make an A? Okay, it's a very practical type of question. You have 20 students in a class, okay, 20 students, and 3/4 of them make an A. So how many people make an A? So 3/4, remember thinking back to your pie, that means if you divide the pie, or in this case the class, into 4 equal pieces, then 3 of those pieces is how many people have an A. So what it's telling you is a majority of the class has an A, which is very good, okay, and you're just trying to find out how many. So you're going to multiply these things together to figure out, you have 20 students, if you multiply by 3/4, you're going to chop that number down, you're going to chop that 20 down, and you're going to find out how many students have an A. So you're multiplying. 3/4 of the class, that's a key word I told you about, usually means multiplication. So we're going to multiply. Okay, what we're going to do is we're going to take 20, and we're going to multiply by 3/4. And this is going to give us a number of people with an A. We have 20, but we're chopping it down because this is a number less than 1. It's going to chop this down, and it's going to tell us how many people have an A. So we need to make this into a fraction, and the easiest way to do that, because it's a number, is we can just write it as 20/1. Okay? Any number can be written as a fraction like this. Okay? And when we do this, we just multiply the tops and multiply the bottoms. 20 times 3 is going to give you 60, and if you're not sure about that, then you can just multiply it out. 20 divided by 3, multiply by 3, you can just do it. 3 times 0 gives you 0, 2 times 3 gives you 6. So you're going to get 60 on the top, 20 times 3 gives me 60, and on the bottom is 1 times 4 is 4. Okay? So you get 60/4, but this is an improper fraction, so we want to simplify it. We want to put it into a mixed fraction form. So the easiest thing to do here, because this is division, we're going to go ahead and actually divide it. 60 divided by 4. Okay? How many times does 4 go into 6? Well, 4 times 1 is 4. Okay, so that's good. 4 times 2 is 8, and that's too many already. It doesn't go 2 times because that gives you 8. So it only goes 1 time here. And once we have that, 1 times 4 gives us 4, and we subtract. 6 minus 4, subtracting, is 5, 4, 3, 2. Subtracting 4 gives us 2. And after we've done the subtraction, we always drop down the next digit. 4 goes into 20 how many times? That's another way of saying 4 times what gives you 20. From your multiplication tables, that's 5. So what we're saying here is, once we do this, 4 times 5 is 20, and we subtract and we get a remainder of 0. So 4 goes into 60 an exact amount of times because there is no remainder left over. It goes 15 times. So this fraction, 60 divided by 4, 60 over 4 is 15. Because that is exactly what a fraction is. It is division. So 15 students. Okay? So if you have a class of 20 and 3/4 of them get an A, that means 15 students get an A. And that makes sense because this is, it's a majority of the class. It's almost 20, and we said three-quarters of a class. That's a majority. So this makes sense from a ballpark point of view. So in this section, we've done word problems involving multiplication of fractions, which actually isn't that hard, especially compared to adding and subtracting fractions. You don't need to find a common denominator. You don't need to do any of those tricks. You just put the fractions into top number, bottom number form like that. If you have to convert from a mixed fraction, you do that. And then you multiply the tops, you get the new top. Multiply the bottoms, you get the new bottom. And then a lot of times, you'll have to simplify that if you have an improper fraction there, or if you can just simplify that fraction, and that'll give you the answer.